Okay, this is going to show how to diagnose a problem with your neutral safety switch on a 97 Corolla. I'm underneath the driver's side front, which is the position of the neutral safety switch. This is called the park neutral position switch in the Corolla manual. And about the last couple of weeks I've had trouble starting in park. If I try shifting or wiggling the shift indicator, or it's an intermittent problem, and most recently I did try shifting into neutral to start, and I do have a suspicion that it could be this park neutral switch. I've had that problem before on my Honda manual transmission with the clutch switch, and it was behaving very similar. I want to get this diagnosed because I don't want to get stranded on this car, and this is a situation where it will not start it. You'll have to find some way to get the starting circuit to operate, and there are various techniques with the screwdriver and the starting motor and trying to jump it like that, but here I want to try to diagnose this problem. Okay, so my Haynes manual does give me a diagnostic procedure for this. It shows right here, for example, on the 97, what the functionality of the park neutral switch is. When it's in either park or neutral, terminals 5 and 6 are shorted to each other, and that closes the starting circuit, and that allows the thing to start, and it will not start in the other positions because that is not closed. Now, the way to test for this is to take a spade connector. That's the, you can see the 5 and 6 of those spots right there. I got some just some wires. I put on some spade terminals on them, and I was able to connect this up to my ohm meter just to test for the impedance of the switch. And I'm in park right now, and I'm reading 1 mega ohm, so that should be a short, so that's failing. Now, the reason for this safety switch is so that you don't accidentally start the car when or start the starting motor when it's in gear, when it's not in park, it's in drive, and the car will lurch forward. I'm going to move this now to reverse just to check that my setup is working properly. This should be an open circuit according to the little chart. If the switch is working, that would be open, and it's open there, so that part's working. That's not really the problem. The problem is that this low impedance closed switch in neutral or park, it fails over time. This is a 97, so that's 22 years old. Now in neutral, I'm reading 57 k ohms. That also seems bad. Okay. One indication of this switch is that it can be intermittent. It doesn't necessarily be bad every time. So I'm going to put it back in park. I've run this test several times here. Now I'm reading a very high value, so this could be bad. But I have gotten results as low as 10 or 20 ohms, 30 ohms or so. I do think the problem right now is with the switch. Okay. So there are ways to bypass this switch. Bypassing the switch would allow you to crank the engine even with the switch not working properly by jumpering the terminal black wire 5 and 6. It turns out it's the black wire and the black white wire. They are thicker, heavier gauge than the other wires. And what I did was, with a razor blade, I scraped away the insulation on those two, and I just patched in some wire I had lying around. This is the kind of wire you buy for a lamp. I soldered it in because I wanted to get a good connection. It is a relatively heavy gauge wire, so a significant amount of current will have to flow through the starting circuit. I covered it with this silicone electrical tape. I find that works really nice. It seals good, so this repair probably should be okay. I have a piece of this which is about 3 or 4 feet long, and I Right now I just have it going up into the engine compartment. I can short the end of that, and that would bypass the switch. And I don't have to climb underneath the car in order to do that, and I don't have to take off the splash panel. I can put the splash panel back on, which I want to do. And next time I have a problem, which will probably be rather immediate, I can short that switch to start the engine. That will definitely confirm that this is the problem. Okay, and this can be a short-term solution until I want to get this repaired. This switch also has in it several other functions. This is responsible, I think, for turning on the backup lights, for example. So this could begin to fail in more serious ways. But this is the bypassing of the neutral safety switch in a 97 Corolla. Okay, thanks. Okay, this is a follow-up to my previous video on neutral safety switch diagnosis, and in that I was getting what looked like a bad neutral safety switch. I was getting like 50 to hundreds of k ohms, up to mega ohm for neutral and park position of the switch. Now here's my Haynes manual shows this measurement, and it's actually showing 0.4 ohms on this measurement. Now, based on that, I thought my neutral safety switch was bad, so I put in a jumper wire. Before doing it, though, I did double check my connectors, the spade connectors that I had used to connect onto this connector, and I inspected those with my inspection mirror to make sure that they were really on the spade properly, and they did appear to be that way. I believe my measurement was valid, so I put the jumper wire in, so in case my car was having a problem starting, I would be able to use the jumper wire. Now, to get the jumper wire in, it was difficult to solder it, so I used this type of solder flux that's used for plumbing. I could get a lot of solder on the large wire, and I had to use a very kind of a heavy-duty soldering iron. This soldering iron is basically it was a craft soldering iron that was used for soldering stained glass. I started off with the electronic soldering iron, and that didn't work so good. But I did get the jumper wire soldered in, and I've been able to repeat my measurements with the soldered connection, which I have up here. Now, with the soldered connection, I did try using the jumper to start the car in the case when it wasn't starting. I wasn't turning over, and it didn't actually help it. So I was a little bit surprised about that. I tried repeating my measurement with the soldered connection, and here's an example, for example, where the car's in park. The key is out of the ignition, and if you look at the diagram here, the schematic diagram, in that case, in measuring between the black wire and the black-white wire, when I'm in park, I should be getting a short, very low impedance, but what I'm getting is 59 k ohms. Very, very similar to what I was getting with the other connection. I can't honestly understand this completely, because it indicates that this switch is bad. And by the way, I get the same measurement even if I disconnect. Oh, I should say that if I measure voltage, I get 0. And if I disconnect the battery ground, it doesn't affect the measurement. Now, the reason I say that is because if you look at the schematic, you can tell that on this vehicle with the automatic transmission, there is a connection into the engine control module at this point, and that could, in principle, provide a secondary path, a bypass path, which could affect the measurement of this impedance that I'm measuring between these points. So when I had the connector disconnected, that isolates the switch. Because when I remove the terminal, the connector from it, it's strictly a mechanical object. So honestly, I can't say that I understand this measurement because it looks like I'm actually getting 49K or actually and even higher values from the switch. But it doesn't seem to be the problem, because when I put on the jumper wire up at this point between the black, white, and the black, it still does not turn over. Now that implies that there could be a problem in the starting motor. So based on that, I did focus on the starting motor, and doing a little research on the starting motor symptoms, I did realize that the problem is likely to be in the starting motor, because although I didn't include this in the video, when I did turn the key to the start position, it was a click, but no turnover engine. And that almost does imply that the solenoid was clicking. And that wouldn't have happened if there was a problem in the neutral safety switch. In the neutral safety switch, if that were not closing properly, when you turn the key to the start position, really there would be nothing, no sound. The only click would be just from the ignition switch, which is a different type of click from the solenoid. So based on that, I did begin to think that my problem was in the starting motor, and my neutral safety switch was okay, even though these electrical measurements look difficult to explain. I don't understand them, honestly. But I was more or less convinced that I did have a problem in my starting motor. I wanted to roll out the neutral safety switch first because I could test it without removing it. The starting motor cannot really be tested without removing it. The starting motor, but at this point I was more convinced that there was a problem in the starting motor. Now, starting motor, to get at it, the Haynes manual also has a procedure for doing that. It's down under there. It's quite a ways down, and in this Haynes manual, they recommend removing air filter, that contraption there, and actually removing this from the above. But on the internet, nobody did it that way. You'd have to remove quite a bit more than what they actually mentioned in here. There's a lot of wires, cables, and things that would have to be disconnected. And the easier way is actually to get that out from underneath. Now, and here's the way that works. Let me get my flashlight here. The way to get this out is actually through the space here. It's through this space. It's the space in the wheel well when you take off the splash guard on the passenger side, and then you look through there, you'll see that you do have access to the starting motor there, and by going under, it's not difficult to disconnect the electrical connections and the one of the bolts from underneath that is holding the starter motor in. The other bolt you can get out from above by taking off the air cleaner and what have you. That does give you access to the bolt from the top. And then the starter motor will actually fit down through this space and it can be removed. And you could either replace the starter motor with a rebuilt one, but it's also possible to inspect the solenoid and or rebuild the solenoid. And based on what I saw on the internet, it's quite likely that a rebuild of the solenoid would solve the problem. So I actually got this online. It's a starter solenoid repair kit, costing about $17. The rebuilt solenoid will be about over 100, new solenoid over 200. So this is significant savings if this in fact were the problem. Now, the way the solenoid works is when it's activated, this plunger, this plunger will actually close a circuit. And what the circuit is between these two copper conductors, and the way this circuit is closed is by this plunger. See the copper perimeter right here, it goes all the way around. Just have to get a good focus on that, but when it closes with the solenoid action, boom, it goes down and it closes the circuit. That allows the current to flow into the starting motor. Now this, if you look at it, does look significantly worn down. Okay, it's not worn down to nothing, but this side is worn down quite a bit. Whereas on the other side, I noticed it wasn't really worn down in thickness. And I think what was happening is it was not wearing evenly. And when this came down, it would hit one side, but on the other side, it must have started getting some arcing, I think, and it was having trouble making the contact, and it was wearing down unevenly, and I think that's why it was not getting a good connection. So I did do the rebuild, and when I saw this, I had kind of good confidence that that rebuild would solve the problem, or that it had a good chance. Now it turned out, after doing that, I didn't have any trouble. I haven't had any trouble now for the last week. No intermittent starts. It's been starting up every time. So I really do think that this is a solution. So I just wanted to finish up this whole issue with the no start, no turn, no turning over on the starting motor for my 97 Corolla.